Hello guys, how are you doing? Let me trust you're doing good wherever you are. It has been a while since we make a video. So welcome to this video today. I'd like us to discuss about the voltages required in the laptop motherboard. I know sometimes it is tough for us to diagnose and repair motherboard, especially when we are not sure which voltage we are supposed to get at a particular component. It will be not easy. It's not easy. So as a technician, you need to understand which voltage you require in a certain part of the motherboard, and it will make your work easier. So we are going to use these two motherboards I have here to do the illustrations of what I'm going to share. First of all, I think I have some notes here. I'm going to share some few notes about what I'm teaching, that is the voltages within the laptop motherboard. Then after that, we are going to illustrate using these motherboards. We are going to measure together at this particular point. We are going to confirm those voltages. So allow me to share the screen. Just give me 1 minute. Just 1 minute. Yes, yeah, I got the notes. Yes, this is my screen. Yes, I believe you are going just a little bit back here. So we are going to use this diagram. This is just a sketch. This is a sketch diagram which represents the laptop voltages requirement. So this is a diagram which shows the voltages. As you can see, I know you can, as a technician, you can just figure out what this is. Yes, it's not about me to give you every detail of it. Here you can see you have the power adapter here, which is 18 voltage. Yes, it means you can plug into your power adapter which supply 18 voltages, or we can use a battery which have about 10 voltage, that is 11 voltage. Yes, depending on how much your battery can store, that is the voltage you can get from your main power line. This blue triangle here, which is labeled V in represents the voltage in, so it means this is the entire main power line. Yes, so this is the entire main power line. This main power lane will have the step down voltages, so meaning after this main power lane we'll have some step down voltages. I don't know whether I can have just a minute. Let's just see one of the, I don't know whether it is this page. Yes, yes, let's use it. Can you see this? So this diagram, so that triangle which we encountered earlier represents this voltage in is the main power lane. So we can power on the main power lane with either the AC adapter or the battery. As you can see, when the voltage from battery is coming in, you have voltages going into the main power lane, and you have some voltages coming into the battery. So when you plug in your adapter, you will have voltages applied along the main power lane, and you will have some voltages going to charge the battery. But when you unplug these, you will have only voltages coming from the battery. So meaning your laptop will power on from the battery. From the main power lane, we'll have the step down voltages. As you can see here, you have the first step down voltages. This is 5.0, 3.3 always on. Then apart from this always on, we'll also have the 3.3 LDOs or FIREX, the 3.3 FIREX. Those 3.3 FIREX and LDOs can be used by the SIO and the BIOS chip to operate. So as you can see, this was the step down one, whereby we have the 5.0, 3.3. Apart from step down 1, we also have step down 2. This step down 2 will have the voltages for the RAM, which depending on the type of RAM you're using, will get the specific voltage for that RAM. So it varies whether you have PC1, PC2, PC3, PC4, PC5. All those voltages varies depending on the type of RAM you're using. Again, here we'll have other step down voltages for the PCH. And under the PCH, we say do you have what's called MCH, ICH. MCH, this is the memory control hub, and ICH, this is the input control hub. So these two main chipsets are the chipsets which are found within the PCH, and the PCH, we know it is the platform control hub, which controls the communication between the CPU and other peripherals. Under step down 2, we also have other step down voltages for the CPU core, that is 1.0, and so on and so on. So I don't want us to discuss more about this because this is not the agenda of today. Our agenda of today is part here. This is the agenda for today. We are going to discuss these voltages for the specific parts of the motherboard. So we said we have step down 1, whereby we have 5.0, 3.3. Apart from the always on voltages, you can see, let's start from down here. Here you can see you have USB. USB should have 5.0 voltage. DVD writer, this is a DVD player, should have 5.0. Hard disk, the operating voltage for the hard disk should be 5.0. So these voltages, you can get them on the positive line of those ports. So be it the USB ports or the DVD player, the positive lines of those lines, you will get the 5.0 voltages. So when you measure the positive line of the USB, for example, in a USB, I'm going to show you. You will have 4 terminals, of which the side by side terminal, another one is the positive and the other one is the negative. So the positive terminal of the USB, whichever the USB, that will carry 5.0 voltage. Then apart from this one, you also have the speaker. A speaker also uses the 5.0 voltage. You have also what? You have also the fan. The fan also uses 5.0 voltages. So the positive lines of those parts, that is the speaker, the USB, the fan, they should have 5.0 voltages. So when you are experiencing an issue with your fan, maybe you have a fan error, or you have a problem with your speaker or the USB ports, first of all, you need to check whether that port is getting power. Then after that, where you can measure checking whether you have any signal coming to those ports for the fan. Sometimes we experience an issue with the fan error because the fan is not able to power on, since we don't have the voltage for the fan, or a certain MOSFET which controls the fan is faulty, or you have the fuse which has blown up, which will have supplied the 5.0 voltage. So those cases whereby you will miss some voltages, it means that you will encounter a problem. Then you have what's called LCD supply, so the power for the screen 3.3, card reader 3.3, temperature sensor 3.3, audio amplifier. So this is the audio amplifier IC, which will also have 5.0 voltage. Then you have audio codec chip. This is 3.3 voltage. What is the difference between the audio amplifier and the audio chip? So this one is an IC which is responsible for conversion of digital sound to analog sound. And this one is an IC which is responsible for amplification of the sound. So for amplifier uses 5.0 and the audio codec uses 3.3. Network chip uses 3.3, BIOS chip uses 3.3. So this BIOS chip at pin number 8, that is where you can get the 3.3 voltage. So whenever you find out that you don't have any voltage on the BIOS, so meaning your BIOS is not able to power on, since it doesn't have the power. You have the clock chip 3.3, SIO, okay, BC 3.3, SIO, this is a super IO, this is system input output system. Okay, BC, this is a keyboard controller. This is a big IC which I'll be showing you, which is found within the laptop motherboard, and it is responsible for controlling all the power within the motherboard. That's why this IC is called mini computer. It's called mini computer since it is able to manipulate. It's able to enable other ICs. It doesn't control the power directly, but it sends out the signal to those PMICs which control power. Then you have the DDR2. DDR2, this is a type of RAM which uses 1.8 voltage, and this 1.8 is called the VDD. Then you have terminating voltage, that is the VTT 0.9. So if this was the DDR1, and remember in my previous video we discussed about the types of RAM, whereby we say the PC1 is also called DDR1, PC2 DDR2, PC3 DDR3, and so on and so on. So for the PC1, if this was the PC1, here we will have 2.5 voltage, that is the VDD, and the VTT should have been 1.25. So in short, the terminating voltage of a RAM is half the voltage, that is operating voltage. That's why this one DDR2 is having 1.8 VDD, 0.9 VTT. DDR3, it will be 1.5, the other one 0.75. DDR4, 1.2, 0.6. DDR5, 1.1, 0.55. Then you have SBD voltage, which is always the same. So the 3.3 is always the same for all types of RAM. Then here you have what's called the ICH. ICH, we say this is the input control hub. So this is a chipset within the PCH, and the voltages for that chipset is 1.05, 1.5, 1.8, 3.3, 5.6, 5.0. So here, ICH. So these are chipsets which control all the inputs, outputs. That is why we love the 3.3, 5.0 voltages here, since this chipset controls all the inputs, outputs, including the USB ports, the audio ports, the speakers, the fan, all of them are being controlled by this chipset. Then the MCH, we say this is MCH, that is the memory control hub. Memory control hub, in other words, called the north bridge. Yeah, in fact, this one is south bridge, then this one is the north bridge. So memory is the north bridge. This one controls the communication between the CPU and high-end component. The high-end components are the components like the RAM and SSD. So meaning this is the chipset which is responsible for ensuring that the CPU is communicating with the RAM. And the voltages for that chipsets are 1.05, 1.5, 1.8. It's the same as the ICH, since that is the one chipset. So the PCH and ICH are one chipset. That's why they are using the same voltages, except that the ICH needs 3.0 and 5.0. I don't know whether I'm making any sense. If I am not, please make sure I do. Then you have the CPU. The CPU, this is the central processing unit of your motherboard, which needs the one voltage 0.8, 1.05. So those are the operating voltages for the CPU. The reasons why we need so many voltages within these chipsets is because they do a lot of work. Yes, they do a lot of work. That's why you need them. I don't know what I have ever mentioned about the states of a laptop. If I haven't, let me hope you do understand. We have what's called the state of a laptop. This is the state at which your laptop is at, whether it is in a sleep mode or not powered on or fully powered on. So those are the states. So among these voltages, there are some voltages which are available at only state 4, state 3. Then at state 0, that is when the laptop is fully powered on. That is when you expect to find all of these voltages available. So I don't expect you to be asking question. Maybe you're saying you cannot, you don't get 1.05 in the CPU, yet you don't have any short. And maybe in that case, your laptop is not yet even powered on. So you cannot get these voltages, not until the laptop is fully powered on. Yes. So at state 4 and 3, we'll have the voltage from the main power lane, that is the main power lane voltages, and then we will have what's called always on voltages. Always on voltages are those voltages which are used to do those voltages which we get from the step down one. The rest of the voltages are not available until you switch on your laptop. That is when the SIO ignites those lights. So I don't want to talk a lot more. So let me just so let's go back. Let's go back to motherboards. So I said we are going to use these motherboards to do some illustrations. Yes. Remember we talked about the USB ports. As you can see, this is the USB port. One of the USB ports. Yes. This USB port here, you have 4 terminals. 1, 2, 3, 4. The 4 terminals, one of them, this far end, it could be the ground, then another one is positive. So whichever the terminal, if this one is the ground, be sure the other one is the positive, and the vice versa are the same. All the USB ports, not the HDMI or the Ethernet ports or the USB-C. I said the USB, this one. Yes, this one. All of them. Yes, even this one. I don't know. Oh, sorry. This one, I don't have the USB for this. But anyway, it's good we have this one. I have another one here. As you can see, this is another USB port. So this is the 830G5. This USB port, you can see it is having pin number 1. In fact, it is labeled pin number 1, 2, 3, 4. So if this pin is the ground, the other one is the positive. If the other one is the ground, this one is the positive. So the pins at the far end. Yes, the pins at the far end. Yes, for this one, pin number 1, then you have the other one, pin number 4. So both of them. So the middle one, the middle pin at the what? The middle pin at the data lines. So we are going to use this meter. We are going to first. Let's start with this. Let me just put aside this one. Let's start with this motherboard. We are going to start with this motherboard. And then I'm going to plug in the power. And before even we plug in the power, can we confirm which pin of this USB port is the positive? Let's confirm. Let's confirm first. How do you confirm which one is the ground, which is not the ground? Yes, by using the meter continuity mode. Meter continuity mode, or the pipping mode. Yes. There, I have resistance mode, but I need the pipping mode so that you can hear from your hand. So there, yes. What am I doing? I know some people when you do this, they say you're testing the meter whether it is operational. No, guys. Every now and then you find someone doing this. We are trying to establish the baseline of the meter. Yes, we are trying to locate to see how much is the. So what is the resistance of the probe? That is 0.1. So it means that 0 resistance. So any value which I'll get, which is almost to that value, it means that it's shorted. So when I do this, it doesn't mean that I am trying to see whether the meter is coming on or not. So how do I check for the ground? Yeah. Anyone? So this is my meter. This is my port. So my probe, the ground, this screw hole here, you can use this one. Then the first pin number 1, there is nothing. Yes, once there is nothing, it means that's not the ground. So I'll code the last one. I don't have when to go to the middle. I'm going to the last one. The last one shows what? 0.1. So it means that the ground. So meaning this positive line here, this first terminal, this one, is the positive of that port. Can we test whether that port is having any voltage? Yes, because we are after the voltages, so I don't want to talk a lot. After the voltages, so I'm going to plug in my power. When I plug in, LED is blinking, so meaning the motherboard should look power on. Yes, it's not powering on since it has the CMOS. I believe I have the CMOS from the back. So let's check to see whether we have any voltages. Your meter into the voltage mode. Then your plug probe always to the ground. It's always to the ground. We say pin number 1 higher. Can you see these guys? Anybody, why am I not having any voltage? Huh? Does it mean this port is not working? I know now I'm confusing you. Yeah, I like that. When you get confused, I really like it because it's good you be confused that you do understand. So the reason why you're not getting any voltage is because this motherboard is not on yet. Right? Yes, this motherboard is not on yet. So the only voltages which I can get right now when I plug in this one. You can see the LED is blinking, so meaning the EC has recognized the presence of the power adapter. That's why the power supply is reading 21 milliamps. So the motherboard is in standby mode. It's ready to power on. So the only voltages I can get from this motherboard is the voltages from the main power line. The voltages from the main power line, you can see, I have 19.71. 19.71. Nice. And again, apart from the voltages from the main power line, I'll also get the voltages from where? The always on voltages, that is the 3.3 and the 5.0. And those voltages I can get them from, I believe, these inductors, not this one, or this one. That is, yes, I can get it from here. It's 1.8. Then I should have another one somewhere, 0.2. We did the, yes, here there. Here there. So this is the 3. I should have the 3.3. Yeah. Why are they not there? I should have the 3.3. That is the 3. So this is 3 or 3. So that is the 3.3. Then I also need to have the 5.0 somewhere. Where is that power supply for that thing? This is 72. 72. Yes, I believe it's that one. This one. I should get 5.0 here. I'm not getting. Anyway, what about the BIOS chip? Can we get the voltage at the pin number 8? Yes, you can see at pin number 8 you have 3.3. Nice. From there, I'd like us to make sure this motherboard is on. Yes, so that you can check all the voltages. You can see when the motherboard is not on, there are some voltages which are not there. So you cannot fully diagnose, you cannot fully say you don't have certain voltages before your motherboard is on, right? Yes. So I have removed the CMOS battery. So let me hope by now when I plug in my power adapter, this motherboard should power on without me switching it on. The reason I remove the CMOS is because I don't have the switch for this motherboard. So when I plug in, and the motherboard is starting at 500 milliamps, 450, 300, 600. So the motherboard is on. Now I like us to wait until it is we are going to test the voltages here for the port. We say we need to check the voltages at the port. Put it here. I believe you can see my meter there. Then ground, then to positive line. You can see that 5.0. Yes, we have the 5.0 there. Why? Because the motherboard is now on. You have the 5.0 there. Apart from that, we say what again? What about what was the other connector? The speaker in the fan. Yes, the speaker in the fan. The speaker in the fan are here. So first, this is the speaker. So where is the positive line of the speaker? Is it this one? No. No, the laptop goes off. Don't know why. It shuts down. About the fan. Yes, you can see the fan also. The fan also is having 5.0. I don't know why am I not getting the voltage for the speaker. Because again, you should have some voltages here. You know, these motherboards are here to be repaired. So maybe even that is the reason why this laptop came in. or they need me to plug in the speaker there. Anyway, we are not going to do that at the moment. Then, apart from that, which other part we say we need some voltages? Okay, let's use this other motherboard. I believe this one has some parts which it will help us. So this another motherboard. This is 840. I believe this 840 G7. This 840 G7. This 840 G7. Okay, let's plug in the power. Let's plug in the power for this motherboard to power. And the motherboard is 30 milliamps, 12 milliamps, 77 to 90, 300, 500, 600. So the motherboard is on. So once the motherboard is on, we are going to test whether we have the voltages for the speaker. So this is the speaker connector. The speaker connector. Remember in our notes we say the speaker should have what? About 5 voltage. Not about. Should have 5 voltage. 5.1. You can see that. You can see clearly. Bring it close. Here. It is restarting. 5.1. That is the speaker. What else? What else are we having? Then apart from the speaker, we had what? Oh, let's check for the CPU. Yes. Let's check for the CPU. Let's check for the CPU. The CPU, these are the coils which powers on the CPU. Remember what we talked about let me just share a little bit. Let me just share back a little bit the voltages we said we should have on the CPU. Just give me a second. Yes. You can see here under the CPU we have one voltage 0.8, 1.05, MCH 1.05, 1.05, 1.5, 1.5. So meaning among these coils we are be sharing, we need to have several voltages. It could be 1.05, 0.8, 1.05, and so on and so on. And again, I forget to test for the RAM in the other motherboard, but we are going to test with this motherboard. We are going to test for that DDR. So this is DDR4. So what you expect from the DDR4, we are going to expect 1.2. That is the 1.2 voltage for this. Then for the SIO, in fact, again, we are going back again to test the other motherboard, SIO. We are going to test the SIO, BIOS chip, network chip, and any other thing we are going to test there to share. So let's continue with our motherboard here. So we say for the CPU, we expect 1. Yes, the motherboard is on. So we expect 1.1, 1.05, 0.8, and what? And so on. So let's start with this one. This first inductor here. What is the output of this? 1.8. Were we having any 1.8 there? I believe there were. Yes, 1.8 for MCH and ICH. So meaning that first inductor, this one. So meaning this 1R5 is going to the ICH or MCH. So it's for the PCH. What about the next? The next 1.005. So that is 1.00. That is 1 voltage. Then for the 1 voltage, we say it's going where? 1 voltage is going. 1 voltage is going where? CPU. So meaning that next is for the CPU. Remember it was 1.0000, not 1.05. 1.005. So meaning it was beyond this. So this is 1.0. This 1 voltage. Then, but from that, next, another inductor, the same one, still 1.0. That is 0.99. That is 1. That was the 1.0. That's for the 1.0. Next, 0.8. 0.79. That is 0.8. Next, 0.8. 0.7, 0.8, that's good. Next, 1.06, that is 1.05. Next, 1.05. Next, oh, this is different one now. So this is something else. So, probably this is for the what? For this card, Wi-Fi card or something. Anyway, what about this? You haven't tested this. This one is not having it. 0.5. Yeah? What is 0.5? So where is that voltage for? 0.6? The CPU is getting mad hot. 0.9, that's one for voltage. So you see now we have several voltages here, but most of them are 1.0, 1.0, 0.9, 0.9. Let's check for the RAM so that we can turn off this motherboard. It's really overheating since it doesn't have the fan. So this is the RAM, this is PC4. PC4 should have what? It said 1.2. And there it is, 1.2. Yes. Let me turn off this one so that you can keep discussing. So, these voltages are very important. Sometimes you might find yourself in a stranded situation whereby maybe you find, did you see here we had what? Here we had the 1.8, for example. So sometimes instead of having 1.8, you might find your this supply, this IC, is not supplying that steady 1.8. Maybe it's supplying like 1 voltage or 0.8. I think what I'm thinking. At that point, you might find yourself stranded because you're not sure. Because if you measure, you can imagine this one should give you what, 1.8, but now it's giving you 0.9, and you know here you have 1.1, 1.1, 1.8, 1. Tell me, how would you be sure? How would you know here we need 1.8? Yes, it will be tough for you. It will be tough for you to navigate along those places. So sometimes we find ourselves in a strange position. That's why I normally tell my students, because actually I normally tell my students it's not about life and death. Yes, sometimes we reach at the end. Yeah, because even me myself, sometimes I get stranded, not knowing what to do. Yes, no, and sometimes maybe it's just something very simple. Yes, it just needs some trick and lucky. So there is nothing like lucky, but you just have to know. Yes, maybe you can try to use the schematic and identify which component is this and how much am I supposed to get out of this. Sometimes you might find yourself in a situation whereby you have a problem with the fan. Maybe you have a fan error or your fan is really spinning very much. So maybe that pin we should have generated 5.1 is generating maybe something like 1.2 or something. Okay. In case you have an issue with that fan, sometimes you find ourselves tapping voltage from the ports, for example. Yes. Did you test the speaker? We didn't. We're going to get it right now. So sometimes we find ourselves in a situation whereby we don't have the voltage for the fan. We can't get the component which should switch that voltage for that fan. And the customer is in hurry. You have so much pressure in your shop. So we find ourselves tapping 5 voltage. So from we say that the ports should have 5 voltage, the fan 5 voltage, the speaker 5 voltage. So do we really need to go for the voltage for the look for that for the fan? Yet we have another 5 somewhere. Yes, it doesn't matter where you get the 5 voltage. What matters is that voltage. You need to get that voltage. You need to get that voltage from anywhere we can get. Yes. So let's check for the speaker. So here we have the connector for the speaker as well on the ground. So this is the speaker. So you can see it. So If the speaker. No, when it is in continuity mode, you're not telling me. So here, I don't understand this. Or is it okay, I get it now. Do you remember when we were testing this? We tried to measure the voltage for the speaker, and still there was no voltage. Same case with this. You don't have the speaker plugged in, and still no voltage. So I think it needs the speaker so that it can read the voltage which is available there. So let's check for the SIO. You said you need to check for the SIO. We're not going back there with the speaker. No, we are done there. Just know you need 5 voltage for the speaker, and make sure your speaker is plugged in before you measure that 5 voltage. Because what are we testing if there is no speaker there? We are not testing the connector, we are testing the speaker. So there, we get the SIO. Yes, the laptop is on. The SIO is this chip. Let me just bring it closer to you. So this big chip. So this is the new button. Yes, the model for this. So this is the new button IC. Yes, we have several types of them. Mostly we have the new buttons. You have the ITs. You have the SMSCs. You have the Novos. You have what again? And all those. So this IC operates on the 3.3 voltage. So meaning the operating voltage for this IC, the input voltage of it should be 3.3. So let's check whether we have 3.3 for this IC. But actually we have it, because if there is none, you see, the input for this IC 3.3. The input I measured is here. Yes, there's a resistor here which is inputting, so you can here. And again, this IC is sending out a lot of signal to several parts of the motherboard. That's why around it you find that most of the voltages which are available there are the 3.3 voltages. Let's check. 3.3, 3.3, 3.3. So this IC is the one I say it is called mini computer. Yes, it is responsible for controlling all the power within the laptop motherboard here. Yes, so this is the new button IC. The new button IC, the SIO or the KBC. Another one is another one. Yes, from a different motherboard. Yes, another one. This one, that one. You can see the new button. Now they have another one. I believe here you can see mostly new buttons. Yes, even this one is the new button. Even this one is the new button. Yes. So that is why I see which is responsible for what? For ensuring that each and every part of the motherboard gets what? Gets the voltage. It's been a tough discussion, so let me hope something is sinking into your mind. Yes. It's good to think. Yeah, it's good because once you understand these things, it will be easier for you to fix any laptop motherboard. The functionality are the same. It doesn't mean that because you've understood for the Lenovo, you not combine that knowledge to use it to fix a MacBook or HP or Dell. Yes, all the laptop motherboards are the same. Yes, only that if this is the new button IT or IC, you'll have another one, maybe the Lenovo or whichever the IC. But the main role is the same. Their role is the same. Yes, to ensure that the power is applied within the motherboard. For example, if this the port's not working, he said any port, not any port, the USB port should have 5 voltage. Yes, it doesn't mean for the Dell should be 5, HP should be 2, Lenovo should be 1. No, all of them. That's why once you understood the functionality of any motherboard, you can understand any other. However, for the MacBook could be a bit trickier, but I'm not saying not doable. It is doable. Only that most MacBooks you find that they don't label their components and they use tiny components. And in fact, that's what makes most of the technicians fear repairing the MacBook. But they are all the same. Only that the components in the MacBook are very tiny and they are not labeled. You know, as we love things which are direct and which are labeled for us. Yes, but the MacBooks company they don't want to label for us. That's why sometimes we find ourselves not liking the MacBooks. But it's good. It's good. Yeah. If you are able, you can also major on doing more research on that. It's good we have so many AI tools which can help us to understand the motherboard. Yeah, I might be sharing some knowledge, but still make sure at your end too you go extra miles to do more research. Yes, and it is really helpful. And as a technician, I normally encourage each and everyone, even me myself. I always challenge myself to get advanced. Yes, it's good to advance at whichever level you are, so that in future, because I am sure in the next like 3 years, 2 years, 5 years, so many new technologies will be available. So meaning, if you fail to advance, you remain stuck there. Yes, in the next 5 years, you will not fix any laptop motherboard. Yes, you'll be dealing with the whole junks. Yes, and some people might end up and calling you the what? Uh, Normally in the field here in Nairobi, we are what called the mkulima. So you might find yourself being referred to as a mkulima, keep fix mkulima. That mkulima comes from the field, whereby you can only fix mkulima laptops, and the mkulima laptops are the old one. Yeah? Yes, so don't be mkulima. Yeah, I challenge you to advance at whichever level you are. It's these things you just need to start from wherever you are. Then make sure you are upscaling. Yes, just upscale up, and things will be easier. Just one step at a time. I don't expect you by tomorrow. You want to be the pro master, yeah, in the entire planet. No, no, no. It doesn't work like that. You just have to do it little by little. Even me, I'm still doing it. Yes, I'm not too old in the field. Yes, I'm still fresh too. Yeah, but I'm challenging myself every now and then to advance, because we don't know in few years time how much technology we shall be having. Yes, maybe we will not be having even laptops. We'll have uh, other things to fix. Yeah, we shall be fixing robots. Yes. So if you don't advance, you will remain there. So guys, thank you so much, and thank you so much for being patient. And please, I'm still encouraging you guys. Please subscribe to our channel. I'm really requesting you please subscribe, share with your friends, and still, if you're interested in learning, we do teach. We are findable offline and online. So we shall have online class starting from March. Yes, from March we shall have enrollment of online class, and also the physical classes are on call. So you can contact me if you're interested in learning. We have the physical classes and online classes, and we also do repair services. So in case you have a laptop which is really disturbing you, or in case you know someone who is having a problem with your laptop, you can send them to us. Maybe we are researchers. You can help them. Yes, and we are happy when we help you. We are happy because we know also you will help us. So guys, thank you so much and see you in the next video. Goodbye.